All right, so this is Who Did I Lend That Book To? Hard Questions Answered with Python. Um, my name is Dan Lindeman. I am a software engineer, senior software engineer at Very. So Very is an IoT consultancy. So they're sort of the ones to blame for all of the kit behind me over here. Um, and if you want to follow me on social, I am that handle on Twitter and that one on GitHub. Um, yeah, so Um, when I work on a talk, I always have to make some assumptions about you. And so if you are coming to this talk, I imagine you probably like libraries, both the Python kind and also the kind with books. Um, but you might also be somebody who's kind of got an unused Raspberry Pi or just kind of a fledgling interest in IoT, and you're kind of looking for some inspiration. So if that's you, then you definitely found the right talk. Um, so you're in good company. All right, so where are we going to go to today? If you want to follow along with any of the code, the GitHub link is on the top of the screen here. And so what we're going to do is we're going to look at the hardware that goes into an Internet of Things project. So at the end of the day, this is an IoT project, right? Internet of Things. So first we'll look at the thing, and we'll learn what all of these words are in just a little bit. And we're going to get the hardware ready to do kind of an actual application project. And so for this talk, I owe a whole lot to this Play Out My Life article, which we'll reference several times, and I'll make sure that I have those in the slides here. But after we look at the hardware setup, then we're going to pop to the internet level. So we're going to look at Flask, set up a Flask server, and then like a little bit of JavaScript. And yeah, we'll have to see how there's like what implications change when we're developing an IoT app, and how that might affect the web server. So why even bother giving this talk? What do I want to share? Well, so I'm from Grand Rapids, Michigan, and I love going to my local library. If you've never been to a city before, I highly recommend going and checking out their library. It's usually one of the coolest buildings in town, and for Grand Rapids, that's no exception. So the front half of it is this big ornate looking historical building. You walk in, it's got like marble floors and like big wooden staircases flanking either side of you. But the back is actually this nice modern cylindrical building that has all the stacks in it. So I really, really like it. And I figure if imitation is the sincerest form of flattery, then maybe I could try my hand at developing a library application. So I was inspired because the checkout process changed significantly from when I was a kid. So when I was growing up, there was a little card in the back of the books, and you would have to like write your name and the date and like some other information. And now I feel old. But in modern times, what you do is you grab all your books, and there's a little pad, and you set it on top of it, and you log into a computer. Boop, boop, boop. It sees all of your books immediately. You say, yes, I want to check those out, and you're on your way. It's magical. It makes everything really, really, I don't know, kind of easy to do, and it makes you feel like just great about checking out a bunch of stuff. So because I'm a technologist, though, I started to like wonder how that was implemented. And so I started looking in the back of every book, and I saw these like giant stickers, right? It turns out this book, or every book now has an RFID tag in it. We'll go into what RFID tags are in just a second, but that's the mechanism by which these books can be scanned into the library's database and handle check-ins and checkouts. So the other motivation was because I was trying to build an Elixir application, and I found myself reaching to Python a lot more often than I was for Elixir. I'm quite a bit better at Elixir now, and so I feel a little bit more comfortable kind of exploring in that way. But I was going to work on an IoT Tiddlywinks game, and yeah, I just found this Play Out My Life article, which uses Python. And I validated my entire hardware setup with Python because I'm still just a little bit faster with Python. It's my first language. But I just thought it was worth mentioning that, even though I was intending to do an Elixir application, Python was still very, very helpful in the development process. So if we are ready to go, let's take a look at the thing level. So um, on the thing level, we're going to be using a Raspberry Pi. I think most people already know what it is. I've got one kind of handy over here as well. They're about the size of a credit card. If you don't know what it is, it's a very small computer that can run Linux. It's really fantastic for making, for learning, and also for making kind of small IoT applications, you know, handcrafted artisanal one-offs. So at Very, we use these a lot for prototyping and for kind of figuring out what can and will work and during development. So it has all like the nice things that you might expect on a full system. It has a lot more peripherals than most of the things we wind up developing, but it's there. So when you get started with a Raspberry Pi, one of the main distributions of Linux that you use is something called Raspbian. So Raspbian is basically Debian or Debian Linux, but flavored to the Raspberry Pi. And as soon as you boot it up, you can actually start a terminal and type Python and boom, you're there. So this is like one of many and Python is there to help slides. But it's worth calling out. The Raspbian image has other languages installed by default, but they're not all quite as pleasant to work with as Python. So we can see this is running Python 5.3.5, which is what comes with Raspbian, or at least it did when I was working on this application. I prefer later Pythons. 3.9 is lovely, but just it's already there. It's out of the box, batteries included, so that's pretty cool. All right, so before we get into this, what is RFID? So RFID has a lot of uses, and it's not really that hard to invent one. Basically, like if you have a thing and you have an ID and you want to tie those things together, you're going to use RFID. It allows for contactless information passing using radio waves. So there are several kinds of RFID, and they all have different characteristics. The one we're going to be using today is passive. So they're basically used everywhere. I've talked about it in the library checkout process. I'm a big Nintendo fan, so they're all in the amiibos. A lot of people here probably used to use access cards to get into their buildings, or if you went to the Fire Festival, that's also RFID. So they can also store a little bit of data. We don't really use that so much here. I know that Amiibo do store off a good amount of data for game saves and progress of things, but we use it a little bit here, but not it's not kind of like the main feature. So the main reason RFID is a useful technology is because of how long passive tags last, which is forever. The power all comes from the reader, right? So there is no power in any of these little tags that I bought. They don't have a battery in them anywhere. They're just powered by the radio waves coming from the reader. So they also fit into a tiny form factor. I just showed you an entire set of stickers. So this is 10 RFID tags, I think. Yes, 10. And you can put them basically everywhere, right? Anywhere you can fit a sticker, you can tag something. So that's why they're in like key cards you can fit in your wallet. There are also active ones. Active RFID, however, requires a power source. So a common application for that is for like cattle tracking. The nice thing about those is that their range is substantially larger. But again, for context of this talk, we're talking about passive RFID. So when you're considering the characteristics, power, we don't need to power it up. Data, it can store data, not a ton, but it can actually store some. And the size of it, those are the three like really big boons to why you're interested in RFID. Cool. So before you get anywhere, you're gonna actually have to buy things. So a little aside that I like to kind of mention here is that I think that the Raspberry Pi gets a reputation for being very accessible. And it certainly is, right? It's $35 for a computer. But there's sort of little hidden accessibility issues with it, which are, you need an SD card, reader and writer. you need another computer unless you buy like a pre-baked image that can write those SD cards. If you're going to do like a traditional like desktop setup, you need a display, cables, a power jack, a mouse and a keyboard. So even though it is a $35 computer, by the time you get all that kind of pieced together, it starts to be a little bit less accessible and less affordable than you might originally think. I mean, it's still a lot better than a full-blown desktop or a laptop environment, but anyways. So with that aside, here are some Amazon links to what I bought. You can see that Amazon is not an amazing place to buy stuff from. I highly recommend not purchasing from Amazon. For the purposes of these supplies, I knew the manufacturers and the boxes, and it looked like the right thing, and so I was able to kind of like make the call here that this would be okay to buy from Amazon. So you can even see the lower one calls out the Arduino Raspberry Pi, which is not a thing that exists because it's either an Arduino or a Raspberry Pi. So the only thing I was really looking for here was compatibility between the frequency of the tags and the reader. So here I'm using the 13.56 megahertz, and so the tags and the reader all do that. So now I did talk about how, Raspberry Pis aren't as accessible as we think, but all in all, even though these prices are a little bit different, I was able to purchase all of this kit for a little over $10. And keep in mind that I bought 2 readers and 50 tags. Most people won't need to buy that many, but I was planning to tag up my entire library back here. So I needed a couple more. Cool. So if you do purchase things from Amazon, I highly recommend getting used to their return process. Cool. So this is the wiring schematic from Pi Up My Life. And I don't think this is very easy to read visually. Actually, in my notes, my speaker notes, I have "good luck if you're colorblind" written down because what are these different colors and how are they all crisscrossed? And I need it looks like somebody tried to connect stuff with a crayon, right? It's still useful, and this is very very much your breadboard, your RFID reader, and your Pi, but it's not quite so helpful to get started because we want to connect the Pi to this RFID reader. So I find this diagram a lot less confusing. So the RFID reader speaks over a protocol called SPI, Serial Peripheral Interface, which is a GPIO-related task. So the reason I find this really helpful is because in this diagram, we have the purple ones in the middle, GPIO 10, 9, 11, are giving us all of the different connections we're going to need to use to speak from our Raspberry Pi to an SPI device, so the RFID reader. The protocols for this are the unfortunately named master and slave protocol. So we have MOSI, MISO, and SClock. So MOSI is master out, slave in, so that's the Pi talking to the reader. And then we also have MISO, which is not only a delicious thing to add to meals and soups, but it is the master in, slave out. So that's the RFID reader talking back to us. The clock exists so that the 2 different devices know when to talk to each other. And yeah, those are the important ones. There are more connections, but that's going to give you basically the gist of it. What kind of data are you sending, and when are you sending it, and in what direction? But I think this is a lot easier to read even than that, right? All this little kind of part of the article requires that is which pin you're looking at and how to count pins, GPIO pins on your Raspberry Pi. If you have a guide like the one I mentioned earlier, do it. In IoT, you don't always get this. So when you have it, one is spectacular. So in reality, once I've wired everything together, this is what it winds up looking like. I just thought it was kind of important to show what it looks like in the wild because it's not very fancy or impressive. It's just a couple of wires stuck between boxes. So the setup is connecting the SPI interface of my Raspberry Pi and then drawing power from the 3.3 volt out. Um, at this point in time, you're probably like, okay, so I've done all the connections, we're ready to go, right? We're not. We have one more little step to tell the operating system to enable that SPI interface, because on Raspbian, it's not there by default. In a framework like Nerves, this is on by default, um, but we're using like a full-fledged OS like Raspbian. It doesn't do that. So we have like one more step of setup. Um, this is not my favorite part of the talk, by the way. I think this is just an important difference that came up when developing something with Python and Raspbian versus something like Elixir and Nerves. In Nerves, those all those low-level interfaces are already enabled for you, so you don't really have to manually do this. This is another barrier to entry, I think, for a lot of people, because this is sort of Linux sysadmin as a blocker. It's a little scarier. It's not like the worst offender I've ever seen out there in the land of IoT tutorials, but it's certainly just one of the scarier parts of the tutorial. If you're just getting started, enabling a interface and then rebooting your Pi is not going to seem like something natural. Great. So now we want to go implementing some code that actually sends and receives over SPI. So we're going to need to know the standards. We're going to need to look at some data sheets. We're going to worry about significant bits, endianness. Oh my gosh. So this is like the daunting part and sharp edges of developing IoT solutions. There are 100 sharp edges. This is a lot more true in the world of Nerves and Elixir. And it's getting better every single day, but it's still very true. In Python, I found something that implemented the entire SPI interface for the registers of our RFID reader. So in the span of about 20 minutes, I was reading and writing card data like a champ. So that library was built on the hard work of dozens of people who aren't me, and that's a lot better in my opinion. So the library is called MFRC 522. So this RFID reader is the RC522. So it's compatible with those. So this is another example of where Python was just sort of there to help. The Elixirland equivalent of this library is not as complete. It has a lot of other cool things, but Python and Pythonistas tend to make things very simple, very obvious, very available. So these two functions on line 7 and on line 13, reader.read and reader.write, are going to be the core of this entire application. And I'm going to use them pretty close to as is, but we're about to find out why I couldn't use them exactly like this. But nonetheless, these two functions will allow you to start reading data from tags, getting the IDs and printing them to the console, or writing data onto the tags to store some information. So now that we can read and write, where do we go? Well, adventure awaits. We've solved the thing layer, and it's time for us to move over to the internet level, which in our case is going to be a Flask server. I chose Flask because it's just the least boilerplate to look at to really understand what's going on. So this is the complete application that we're going to build. This is like my site map. And they're going to be built around those two functions, read and write. So the top level node here, the index, is going to have 3 links. That's going to go to register, lend, and my inventory. So I'll quickly go over index and inventory because they don't really have any of the IoT goodness with it. But inventory is actually the one that I care the most about. So the problem I was trying to solve was that I will buy a book and love it. And then as soon as I'm done with it, I want to lend it out to somebody. So the net effect is my home library only winds up being like this big because I've lent out like 90% of my books to other people. So I wanted to keep track of who had my books. So, inspired by my own library and the need to figure out where my books are going. The inventory page is the most useful for me, but again, it's not that interesting from an IoT perspective. So this is the inventory page. We're using a SQLite database, and we're basically grabbing different books from the inventory and saying, I can return them or I can delete them if one of my friends decided that they were just going to keep the book and I don't get to have it anymore. This is a pretty normal, post endpoint for return or delete. It's just updating some fields in the database. Like I said, not terribly interesting from an IoT perspective, but still, it's there. Cool. So this is what it looks like. So here we see that I've lent out the room to my friend Jace, and I can either return the book or if he decides he wants to keep it, then it'll delete it from the inventory. So it's showing the ID, the data that's on the tag, and then who it is currently lent to. Awesome. So the first page that allows us to interact with the hardware has a bug, and I'm wondering if you can spot it. If not, recall that at the end of the day, we're trying to transfer some bytes. We're going to take a title. So the screen works something like this. You type the name of the book, Gone with the Wind, and you hit submit, and it's going to write Gone with the Wind to the next RFID tag that it sees. It blocks, when you type that in and you click submit, it just sits there in an empty screen and kind of shows nothing. It is a problem. But since I'm the person who's registering books, I could decide whether or not that was like a problem for me. So let's take a look at a short movie here. And this is kind of what it looks like in motion. Cool. So you can see I've got the book 2 Scoops of Django, and I'm going to submit that. And then you see it just kind of like doing nothing, right? It's just spinning and the screen isn't changing. So then I take my 2 scoops, which has an RFID tag in it, and it's going to send us just automatically redirect back to there. So let's check in my inventory. Boom. There's 2 scoops of Django, and it is lent out to nobody. Awesome. So again, if we take a look at why that is, like what happened there, what's happening is that if we look inside the write function, we see a while loop, right? And so that's going to block. Oop, I need to hide that. So if we look inside the write function, it's a while loop. It's a literal, while not ID. And it's basically going to hold that forever. And what Flask is trying to do is Flask is trying to render the next thing, but this function call inside of it that's writing to the RFID tag is just holding it. So it can't actually render anything. So it just doesn't move at all. There is a write no block function. And I tried to work around this. In general, you want to isolate your different peripherals into their own processes. But in Python that's not super easy. I was trying to work around this maybe using Redis and PubSub, which had its own problems. There's probably an elegant way to do this with like async and yielding things. But for the registration process, since I'm the one registering all the books, I was like, this isn't that bad. I type in my thing and I'm going to do one book at a time. I don't usually buy like 20 books at a time. So it was a possible workaround, and it was probably like the hardest thing to walk away from while I was making the like checkout screen, right? So we're going to be talking about the actual like lending process in a second here. Something that I did learn was that Flask can actually render things piecewise from a generator, and I really wanted to get this right, but passing messages in Python between 2 processes is not as easy or as simple as one might think, and it's a little bit out of scope for this talk. So we'll just kind of like talk about the different trade-offs. If you're interested in streaming, I really like the Palette Project's tutorial here. So we knew we had this bug. but it was closing in on when I wanted to kind of like wrap up this experiment, right? Because I'm ultimately working on something else, and all I'm trying to do here is just figure out, well, can I do it? Is there some cool stuff in Python? So I decided to just write a slide about the bug and say that this is now just a feature, and that it's designed that way because, well, I own the library. So what? So we will revisit this bug again. And in write, it's not so bad. In read, however, it's a lot worse. So when we want this application to loan out books, so how can we do that? We think that there's like probably a right way to do this, but let's take a look at the implementation as it is. What's happening here is the read no block is pretty much like write no block. It'll let us pass by it, so we can continue to do a little bit of work. So what I'm doing here is I've set a 1-second timeout for the RFID reader to kind of scan its surroundings and look for books. That's not a very good user experience, right? Because in my public library, they have maybe like a 15 centimeter scan height for all the books. So you can set like a bunch on top. But here, if I had to lend out more than one book, I'd have to scan them all like really quickly in 1 second. But I do this for a reason. So what's going to happen here is we're going to give the RFID reader about a second to look for the books that it sees. And then we're going to break out of that loop. And any scans that I've seen, we're going to add to a set called scans. And then that's what's going to get rendered on the Flask application. So even though we think there's a correct solution, we can actually do something a little bit easier. So the reader is going to have 1 second to look, but Flask isn't going to be able to render anything. And in fact, this was the main problem. I was trying to click buttons in Flask, but it could never pull the context back because that while loop was sort of still taking over. Even though it was just 1 second, I noticed that I couldn't touch any of the Flask rendered pages. So what we can do here, we could either have done the async streaming stuff, or if we truly believe that simple is better than complex, we can add 3 lines of JavaScript to our front end and have it refresh the page every quarter second. So essentially the feature we're getting here is a trade-off between the RFID reader reading and the Flask app being able to render something. And so I found that this was a reasonable way to get some feedback and allow me to click the buttons while still giving kind of like a responsive feel to lending things out. So here is the lending process in action. So I go to click to lend books, and I've got my 2 scoops of Django. Click it to the RFID reader, and we see it go boom, pop up there, 2 scoops of Django. Great. So now I'm done, and I want to figure out who I'm going to lend it to. So now I've lent 2 scoops of Django to Jace. There we go. And we go back home. So in this instance, JavaScript is there to help. I know that I was supposed to have a bunch of different slides that are, well, Python is there to help, and I know this is a Python conference, but I think anytime you find a language that's there to help, be it Python or JavaScript, that's a really good thing. So I can't help but celebrate when I find that something is there to get me out of a bind. So since the solution we came up with is serving a single client, me, and it's the only process running on the machine, it felt like a fair balance between correct and done. So lastly, this page is also taking that scans. This is just kind of the second part of checkout process. And we just kind of keep things in that scans cart. And then we assign them to somebody on the next screen. So this is just updating who the RFID scans are that we just found and just adding their loaned to field to the database so that we could go check it out in inventory. And so that is it. That's the entire application. We did it. I want to thank you for spending some time and attention with me. We only get so much per day. And I can't tell you how much it means to me that you spent some of yours on me. And if you have any questions, I'll be available and be around. And I want to give a special thanks to my friend Jace, who helped me put together a lot of this in Python land. If you don't have any other questions, I had some hopefully asked questions, which are, what are your favorite books? I really like Everything is Illuminated and Designing Data-Intensive Applications. If you know those two books, this is a funny joke. If you don't, it's not. So something that I would do differently next time is I would probably do less coding on a Pi. And I would probably actually do those separate services. Now that I've spent a lot of time in Elixir working with processes, I think it really is kind of the way to go. I'd also add tests, a lot more tests, because right now, during the development of this application, there were quite a few guesses being taken. So yeah, thank you very much for your time and attention. If you want any other sources, here are all the things that I had to look at during my time developing this application. So thanks.